Following on from the previous video, our aim is to find out the gradient at any given point on any given function. So we wanted to find out the gradient at A here, and the way we do that is to set up another point B here, work out the gradient of this line, and then slowly move B towards A. Okay, and at the end of the previous video, we got to this stage here. The coordinates at this point here at A will be x, and then the height here is given by f of x. Okay, and the coordinates at B, well, remember that we set up this h here is very important. This h here is the length from here to here. So if this here is x, then this point here, then this here will be x plus h. Well, if this point here is x plus h, if you put x plus h into the function, it will then give you the height. So the coordinates at B will be this. Okay, the y coordinates will be this. Okay, and if you want to find out the gradient of this line here, it will be this height. It would be this height here divided by this length here, which is h. Okay, so the gradient of this line here will be this height. Okay, which is this take away this. If you want to know this height here, if you want to know this height here, it will be the whole length here take away this length here. That would give you what's left here. Well, anyway, the gradient of this line here will be given by this thing here. Okay, and the way we move B closer and closer towards A is for us to decrease h. You see, make h shorter and shorter each time. Well, anyway, here we're going to make h shorter. So our aim is to move B closer and closer towards A. And the way we move B closer and closer towards A is for us to decrease h. Make the horizontal distance here shorter and shorter. That's how we move B closer and closer towards A. Okay, and then eventually it will get closer and closer towards A. So the next step is to make h slightly smaller. Okay, so here make it slightly smaller. The thing is, even though you made h slightly shorter, the gradient of this line here will still be the same. The gradient will still be the same. It will be this, take away this, and then so this here, which is this point here, take which is, well, this here is the height here, take away, hang on, let me start again. So remember, we've decreased earlier. Our h was somewhere over here, but now we've decreased h to here. But we still need to find out the gradient of this line here. The gradient of this line here will be this height, which is this bit here. Take away this height. So it's like it's like this height here being, let's say, 5, and this height here is 7 because it's slightly taller. So you would then get 5 take away 7, which would give you -2, and then you would divide by this distance here, h, divided by h. Notice that because of this minus here, the gradient it's a negative gradient. My point is that even though it's down here, the this whole thing here will still work. It will always be fx plus h take away f of x divided by h. Even though it's a negative gradient, it takes it into account because f of a, let's say this here is 5, this here is 7. 5 take away 7, and then that will give you a minus. Well, it would be a minus gradient. My point is that the gradient, as B moves along, it will always be this. It will always be this, even if it's a negative gradient. It would take the negative into account. Okay, so hang on, back to here. So now so earlier h was from here all the way here. We then decreased h. That's how we move B closer and closer towards A. So our next step is to decrease h even more. Okay, so let's decrease h even more. So here So here, this is your h here. But the thing is, even though we decreased h, the gradient will still be the same. It will be this. It will still be the same. Take away f of x divided by h. Even though we made h to be shorter, the gradient of this line here will always be the same. Even if it's my point here is that our aim is to decrease h. Our aim is to decrease. Well, our aim is to really force h to head towards 0. So hang on. So really, the gradient at A is really us forcing this h to head towards 0. So the gradient at A, we can actually say the gradient at A equals this whole thing here. Take the limit as h tends to 0. You see, earlier we started out with h being really big, and then we made h smaller, and then smaller, and then smaller. Well, basically somehow get h to be next to 0. Somehow get it to force h to head towards 0. So really, we can actually say the gradient at A, the gradient at A is really this thing here. Force h here to head towards 0, and then you would get to a point where you can say, oh, the gradient at A will be given by this. So you can actually say the gradient equals this whole thing here. Okay, I will elaborate more on this in the next video.